Everyone. So we are going to try out the first question, 1A. And the first question is telling us to shade the Venn diagrams below. And we are given a set here where we need to shade. So our first thing that we're going to do is going to be A naught. So not A, everything not A, we're going to shade that, right? And then intersecting with anything, everything that's not B. So when intersecting with not B, we're going to shade something like this, right? Because as long as it doesn't touch A and it doesn't touch B, and finally it doesn't touch C. So for our answer, we're going to shade everything outside of those three diagrams. Okay, something like that. Now moving on to the next Venn diagram. It looks like in the next Venn diagram here, we have a bracket. So it says here B intersecting with C. And luckily that B intersecting C is just shading this part. Okay. Now it looks like the next part is we're going to have to shade A union of what we previously did. Okay. So A union means that we're going to shade everything that's going to be included between those two. Okay. So therefore your answer is just this. All right. Now, let's move on to the next part. So in part B, I'm going to draw some calculations here or workings. Now, our universal is somewhere between 0 to 360 degrees. And P is cos 2x equals to 0.5. Q is sin x equals to 0.5. Now, what we're dealing here is going to be trigonometry, but it's a mixture with sets and Venn diagrams. What I'm going to do first is I'm going to find the sets of P. Now, P is being stated as equals to cos 2x is equals to 0.5. Okay, and the domain for that, I'm going to write it down as between 0 to 360 inclusive. Okay, now before I move forward, I'm going to change this into, I'm going to multiply everything here to 2x because you're not dealing just cos x, you're dealing with cos 2x. So 0 times 2 is 0. This is 2x and this is 270 degrees. Okay, now if we are going to use the ASTC, since we're dealing with trigonometry, let's double check here. The number on the right side here is positive, and we're dealing with cos. So positive meant A, and then cos with C. So A and C. Okay. Now, since we're dealing with domains between 0 to 720 degrees, this quadrant only covers 360 degrees. So you'll have to do a second round of A and C, right? Now, we can now move the cos to the other side, cos 0.5, and now we can find the theta. Our theta is going to be 60 degrees. Okay, that's going to be in the A quadrant. Now, in order to find the C quadrant, it's going to be 360 minus theta, okay, which is 300. Now, once we are moving on to the second cycle of this quadrant, when we're going to go back to A. So what happens in A is we're going to have 360 plus theta. It's a reset, right? You're no longer starting from 0, you're starting from 360. So this will give you 420 degrees. And lastly, for C, it's going to be 720 minus theta, which is equals to 720 minus theta is 660. Yeah. Now finally, we can bring the 2. We can divide everything here by 2. So 60 divided by 2 is 30 degrees. We have 150, then we have 210, and finally we have 330 degrees. So these are our list of P's. Now moving on to Q. Q is sine x equals to 0.5, right? Now I'm going to write down the domain again. Okay. Now in this case, I'm not going to change anything in the domain because we're dealing with sine x, not 2x, not 3x, or x plus something, and so on, right? So in this case, I can just write down my ASTC, and we're only doing this for one cycle. But since we're dealing with sine and the right side is positive, we're going to take A and S. Okay. Now let's move the sine to the other side. And we'll get 30 degrees, right? So this is actually your theta, and then your S is going to be 180 minus theta. So that's going to be 150 degrees. Now, finally, we can move on to answering the question of part B. We want to find P intersecting with Q, right? So P intersecting with Q, which are the numbers that intersects both P and Q? They are 30 degrees and 150 degrees, and that would be your answer. Okay,